Hello class, this is Mr. Eggleston and this is a review of Algebra 1 quiz 1.4 through 1.7. I gave you a bunch of problems that were randomly generated, at least the beginning ones, the ones where you have a bunch of the same kind of problems, like 1 through 6. I'll be honest with you, anything looking like number 4 or numbers 5, don't worry, it's not going to be on your test. I'm not going to give you, like number 4 is just the fractions are just, Just to let you know that I believe is geometric. I think you're multiplying by -4/5 each time. So it's geometric, but this fraction stuff is just ugly. So I'm not going to make you do that. Same thing here. I'm not sure what this is yet. Notice you got 1/2, then you got 6s, then another half here. So it's just ugly fractions. Now you could see something like 6, 4, or 3, 2, 1. Those are decent. You can, and then also here. Now you have a lot of these, but you only have one on your quiz. You have a lot of these, but you only have one on your quiz. And then you have 2 of these, but you only have one on your quiz. And then you have this, which is similar to your quiz. All right? So let's get going. I'm going to go ahead and just kind of circle the ones I'm going to do, like this one, number 1. All right, it says, well, for each sequence, state if it's arithmetic, geometric, or neither. If arithmetic, find the common difference, and if geometric, find the common ratio. The common difference, what you're adding, and the common ratio is what you're multiplying by. So when we look at 1 to 2, 2 to 6, 6 to 24, 24 to 120, you're not adding the same number, and you're not multiplying by the same number. So this is actually neither. Doesn't mean you couldn't come up with or find the pattern. I believe we're multiplying by 2 to go from 1 to 2, multiplied by 3 to get from 2 to 6, multiplied by 4 to get from 6 to 24, and multiplied by 5 to get from 24 to 120. So it looks like we're multiplying by increasing integer values. So the next one, if you wanted to find it, you would multiply by 6. And that would be 120 times 6, which is 720. So I think the next term in this sequence would be 720. But it's neither arithmetic nor geometric because they're not adding the same number and you're not multiplying by the same number. Numero dos, number 2, going from -14 to -6, we're adding 8. Going from -6 to -2, we are adding 4. Going from -2 to 0, we're adding 2. And going from 0 to 1, we're adding 1. So you can kind of see that, well, A, it's not arithmetic. And quite honestly, it's not geometric either. You're not multiplying by the same number. The thing here is there is a pattern to what we're adding. In other words, we add 8, then we add 4, then we add 2, then we add 1. We're dividing by 2 the number we are adding, starting with 8. So it goes 8, 4, 2, 1. Next one would be adding a half. So you could actually predict that the next number in this sequence would be 1 plus a half. Okay, to give us 1.5. But, oh, by the way, it says the 6th term, this is 1, 2, 3, 4, 5. So it's really just the next term in each of these. Number 3, going from -4 to -8, -8 to -16, -16 to -32. It looks like we are multiplying by 2 each time. So it's geometric. And we are, the next term would be -128 because we're multiplying by 2 each time. On 4, ugly fractions, it looks like going from 2 to -8/5, then positive to negative. So that's telling me it's got, if anything, it's going to be geometric because the signs are flipping. And I'm multiplying, to go from 2 over 1 to -8 over 5, you would multiply by a -4/5. Right? Multiply the tops again. This one's just ugly. And then going from negative 8/5 to 32/5, we are multiplying by a negative 4/5. So looks like we are multiplying by a negative 4/5 constantly. This is actually geometric, even though it's ugly. And we are multiplying by an r equal to negative 4/5. So that's the number you're multiplying by. And then you multiply this by negative 4/5, and you would get the next number. Again, don't worry too much about it. I'm not going to give you ones with fractions. They're going to be integers. 5 1/2 to 13/6 to 23/6. Well, right here, we are adding 10/6, which is 5/3. So I'm wondering if we write 1/2 as 6/3, and then 5/3 plus 6/3 is 11/3. No, it's not. I'm going to say this is neither. This is just not pleasant. And again, you don't have to worry, stress too much about this. Okay, going from 1 to negative 6. Notice we are switching signs here. So that means it can't be arithmetic because it's only going to constantly add a positive number, constantly add a negative number. It's not going to be, to switch signs, you have to be multiplying by a negative. So it's got to be geometric, if anything. So to go from 1 to negative 6, we multiply by negative 6. Negative 6 to positive 32, we multiply by negative 6. It looks like it's geometric. And that you're multiplying r, the common ratio, or the number you're multiplying by, is negative 6. So you would take 1296 and multiply by negative 6. And you get negative. The next term is negative 7776. All right. Now comes the more not rudimentary, but just things you should be more familiar with, simplifying. Notice we have parentheses and multiple variables. So we have to simplify, means get rid of the parentheses. So we're going to do the D word, which is distribute. And you get negative 8k plus 8 times 6, I believe, is 48k minus 40, which is 8 times negative 5. Negative 8k plus 48k is 40k minus 40, and that would be the answer. That's the simplified form. On 8, distribute again, you get 6v minus 6 minus 1. 6v minus 7, combine like terms. And that would be the answer for 8. 9, distribute to 7. I hope you all are familiar with distributive property. 21b, you should have seen that last year or in previous math courses. 7 times, now notice, 7 times a negative 4. All right, 7 times a negative is a negative 28. And then we have plus 4b. We have 21b plus 4b. They are like terms. You add them. I believe 21 plus 4 is 25. Oops, sorry. B minus 28. Okay, notice I'm circling my answers. I want you to circle your answers on the test. All right, on 10 would be considered an uglier one, mainly because it's that minus sign right there. So we have negative 6x. Now when you distribute a negative 6 in your mind, right? Negative 6 times 1 is negative 6. Negative 6 times a negative 3x is a positive 18x. You got to make sure you include that negative sign when you distribute. Then negative 6x plus 18x, I believe, is 12x minus 6. This is capitalizing on some previous knowledge. All right. On 11, distribute the negative 8x in. Remember, that's a negative, so you got flip signs. Negative 8x times 2x is a negative 16x. Now, x times x is x squared. You may not remember that. Don't stress. I don't think I actually have you distribute the variable on the quiz. So you don't have, or if I do, you're not going to be multiplying and getting like exponents. All right? That's something we'll cover later in the course. Negative 8x plus 4 is negative 32x. And then remember, you distribute the negative sign. Negative 3 times 7x is negative 21x. And negative 3 times a negative 7 is a positive 3. Now combine like terms. There's nothing similar to the x squared, so it just comes along for the ride. We have to figure out what negative 32x minus 21x is, and that's negative, let's see, when you subtract, you add the opposite, so it's negative 32x plus a negative 21x. When you add, the signs are the same. You combine the numbers, add the numbers, and keep the signs. So 32 plus 21 is 53x. And then we have plus 3. So this one's a little bit ugly. This one's fail. All right. Again, we're distributing with the variables. So 4a times 4a, 4 times 4 is 16, a times a is a squared. Again, don't stress too much about a times a being a squared. We're not really into that yet. We will get there. 4a times 4 is 16a. Now, think of this as a negative 1 times the parentheses. So that might remind you that you have to distribute the negative sign, the negative 1. Negative 1 times 1 is negative 1. Negative 1 times negative 5 is a positive 5a. Now, another way of looking at it is I always say when you subtract, you add the opposite. So I make this plus, but then I would switch the sign of each of the inside terms. So now we have plus a negative 1 and then plus 5a. Either way will get you the same result. So now combine like terms, and you have a 16a plus a 5a, which is 21a, minus 1. These are the harder ones, guys. These are the harder ones. And finally, we distribute twice. Negative 5 times 4p is negative 20p. Remember, negative times a positive is a negative. Negative 5 times 1 is negative 5. 8 times 1 is 8. 8 times p is 8p. Combine like terms. Again, like terms is a phrase we're going to be saying a lot. That just means when you add and subtract, they have to have the same variable to the same exponent. So negative 20p plus 8p, negative 20 plus 8, I believe is negative 12p. And then we got negative 5 plus 8, which is plus 3. And that's the result. Last but not least, again, this is the ugly. And I don't think you're going to have one this ugly. But if you remember how to do this and you get the same answer, awesome. You are awesome. So you got negative 8x times x is negative 8x squared. Negative 8x times a negative 8. Negative times a negative is a positive. 8 times 8 is 64x. Negative 2 times x is negative 2x. Negative 2 times a negative 1 is a positive 2. So we have negative 8x squared. Then we have 64x minus 2x is plus 62x plus 2. So that's all the just your basic algebraic manipulation, combining like terms, getting rid of parentheses, simplifying, so to speak. 15 and 16 are similar questions that come straight off your test, and then 17. And by the way, there's a lot more questions here than there are in your test. Like all the multiple ones on that we just got done doing, I think there's one of each. So don't panic about the number. Like there's only one of 15 or 16. So they're both very similar. 15 is a cell reproduces by dividing into 4. After a certain growth period, the cell will divide into 4 again. So it keeps multiplying by 4. Okay? The cells continue to divide into 4 after each growth period. Make a table showing the number of growth periods and the number of cells. Now, so we have growth periods. The reason you don't have a table here is because I cannot generate a table on the program I use. So this is the growth period, and this is the number. Okay, so a cell reproduces by dividing into 4. After a certain growth period, the cell will divide into 4 again. The cell continues dividing into 4 after each growth period. So we initially have 1. Okay. Then, after one growth period, the cell divides into 4, we will have 4. After a second growth period, the cell divides into 4 again. We would have, so each one divides into 4. So it gets multiplied by 4, and we got 16. Then after the third growth period, it'd be 4 times 16, which I happen to know off the top of my head is 64. And then after the fourth growth period, it'd be 64 times 4, which is a good sized number, which is 256. Okay. Now you can keep this up after 10 growth periods. So they want to know after 10. So I would probably go with 256 and keep multiplying. So 256 times 4, the fifth growth period is 1024, times 4 again. That would be the sixth growth period. So 5 was 1024. 6 was 4,096. 7th is going to be times 4 again, 16,384. And the 8th, so all I'm doing is I'm just multiply by 4 each time. So I take my 16,384 and multiply that by 4. Again, you need a calculator for the test. Now we're up to 65,536. Let me just put commas here to denote placeholders. All right. 9 would be 4 times that. 26,000. Oh no, 262,000. Wait, am I reading that right? 26,214. And that's the 9th growth period, and we have to do it one more time for the 10th. So multiply by 4 again, and now we're up to 1, 2, 3. Okay, 1,048,000. I'm sorry, 1,048,576. And that's after 10 growth periods. So the question is, can the number of cells ever be 4,096 cells? If so, how many growth periods would that be? Well, you can see from your table, yes, it can, because it's right here. When you made your table, you got to the 6th growth period, and the number was 4,096, so the answer is yes. There would be, sorry, my pen needs a new tip on it. 4,096 in the sixth growth period. By answering the first one, we were able to easily see what the answer is for part C. All right, for 16, it's very similar to 15. Notice that reproduce dividing into 4 short growth period. Okay, sorry, this 4 should be a 3. And this 4 should be a 3. I was trying to make a quick change. So the cell continues to divide into 3 after each growth period. So, yeah, it's not 4 because all I did was copy and paste it over. Okay, make a table showing the number of growth periods and the number of cells for 5 growth periods. All right. So you just do the same thing. You start with 1. So we have our growth period and the number. Okay. On the 0, we start with 1. On the first growth period, it divides into 3. So that means we have 3. On the second, it divides into 3 again each, and that's going to be 9. On the third, so we're multiplying by 3 each time. On the third growth period, it'd be 27. Fourth growth period would be 81, which is 81 in your mother tongue, in English. In the fifth, it would be 3 times 81, which is 243, I think. I hope. How many growth cells were to be after 7 growth periods? So we have to multiply by 3 twice because we're at the 5th. So the 6th growth period would be 243 times 3, which is 729. And the 7th growth period, you just multiply by 3 again. Remember, this is a geometric sequence, 2,187. And it would be 2,187. Make sure you circle your answer on these. When it's asking to fill in the table, not so much. Can the number of cells ever be 6,561? If so, how many growth periods would it take? Well, I would just keep multiplying by 3 each time. And it turns out that on the 8th growth period, we do get 6,561, which is just 3 times this. So, yes, 8 growth periods. Okay. On the last one, due to sunlight and evaporation, the amount of chlorine in the swimming pool decreases from day to the next. On a particular day, a swimming pool contains 290 ounces of liquid chlorine. Okay, notice on the table that's given to you. Oh, it's wait, I have 290 there and 246 here. 8, 12. Let's go with, let's not use this one. Sorry, that should be, this one right there should be 246. Okay, so that's at the 0. Then, each time we multiply by 2/3. So take 246, and you literally need a calculator, times 2 divide 3, or times 2/3, you should get 164. Then multiply that by 2/3 again. And now we're getting into decimals. So that's 109.33. Okay, repeating. It's a fraction. Then we multiply by 2/3 again. And you need to have a calculator. And that works out to be 72.89. And then multiply by 2/3 again. And that works out to be 167.64. Okay, so there's the table. And then they want you to make a graph of it. Complete the table and graph to show the amount of chlorine. So at 0, we're at 246. There's 240. Okay, 250, so 246 is right in the middle there. I'm going to use green. There's the first at the 0 point. Then at 1, we're at 164. So here's 150 is right there. So 164 is just a little bit above that. Between, I'm sorry, there's 100, 120. I am way off. 246, I'm at 146, so my bad. The 0 point's 246. So move that dot, move this pathetic dot all the way up to right up in there. There it is. And then it's 164 at 1. That's halfway between 160 and 170. Mind your scales, how much each line is worth. So it's roughly right there. And then at 2, it's at 109. 1, 2, 1. Okay, so this is 110 right there. So 109 is roughly right there. And then 72.9, it's a little bit above 70. So it's not linear. And I'm not sure where the 167 came from. I know what the problem was. That 167 was multiplied by 2.3, not 2 divide 3, not 2/3. So I'll take the one above it and multiply by 2 divide 3. 48.6. So this number's way up. I should have noticed it because we jumped up. And we should be, so that should be 48.6. Okay. So day 4, we're at 48.6, which is right there. And you can see that that is not a straight graph. That's not a line. It's actually something called exponential. Okay, and we'll get into that come a ways away. It's going to be probably second semester when we get to it, but it's definitely not a line. It's curved. All right, and that's pretty much your quiz. So I hope this helped. If this didn't, come see me in office hours or before school, office hours after school today. Your test is next class period, next Thursday, Friday, and this is Wednesday when I'm recording this. So come see me if this is not making sense. Thank you. You have a great day.